Why we can't cure aging. Somewhere in a lab right now, a mouse is living 30% longer than it should. Scientists killed off a specific type of cell in its body, and its heart got stronger, its kidneys started working better, and it even grew its hair back. That mouse is proof that aging isn't as untouchable as we've always assumed. So why can't we just do the same thing to ourselves? The truth is, we're closer to understanding aging than we've ever been. We can now measure it down to the molecule. We know almost exactly what's breaking down inside you right now. And yet, after decades of research and billions of dollars, there is still no pill, no injection, no treatment that stops it. Not because scientists haven't found the switch, but because aging doesn't have one switch. It has at least 9. And every time we try to fix one, we risk breaking another. Let's look at why curing aging is so much harder than it sounds. 1. The cells that won't die. Every time one of your cells divides, it loses a tiny piece of protective DNA at the tip of its chromosomes, like the plastic tip wearing off a shoelace. Eventually, that tip runs out, and the cell can't divide anymore. Most of the time, it just dies, but some cells don't. They become what scientists call senescent, or, less politely, zombie cells. They stick around, refuse to die, and leak out inflammatory signals that damage the healthy tissue around them. The more of them you have, the older and sicker you get. The obvious fix is to just kill them off. Scientists have actually done this in mice, and the results were dramatic longer lives, stronger organs, fewer tumors. But here's the catch: senescent cells aren't purely bad. They also play a role in healing wounds. Wipe them all out, and you might live longer with a healthier heart, but you also might stop healing properly. There's no clean way to remove the damage without removing something your body still needs. 2. The cure that causes cancer. Those same shrinking chromosome tips, telomeres, are also a built-in safety limit. Every time they get a little shorter, your cells are one step closer to retiring. It sounds like a design flaw, but it's actually a defense mechanism. Cells that could divide forever, without limit, already have a name: cancer. There is an enzyme, Telomerase, that can rebuild those tips and let cells divide indefinitely. In theory, switching it on everywhere could stop aging at the cellular level. In practice, that's the exact same trick cancer cells use to become immortal. Push too hard on the aging switch, and you're not curing old age, you're manufacturing tumors. 3. A body that was never built for this long. Even if we could fix the cells, we'd still be working with a body that was never designed to last this long in the first place. Go back far enough in human history, and living into your 40s was already beating the odds. Evolution had no reason to protect a heart that needs to keep working at 70, because for almost all of human existence, almost nobody's heart needed to. Our organs, especially ones like the heart, don't have much of a backup system built in because there was never any evolutionary pressure to build one. We're not just fighting damage. We're fighting a body that was quietly optimized to stop mattering after we've already had kids. 4. The mouse problem. Nearly every major aging breakthrough of the last decade has one thing in common: it happened in mice. Killing senescent cells, boosting NAD+, injecting young stem cells into old brains. All of it has worked, sometimes spectacularly, in lab mice. But mice aren't small humans. Their bodies are simpler, their lifespans are shorter, and biology that works cleanly in a 2-year-old mouse doesn't always translate to an 80-year-old human with a lifetime of accumulated damage. Getting from "it worked in mice" to "it's safe and effective in people" takes years of trials, and most of those trials haven't even started yet. So, when you put it all together, the reason we can't cure aging isn't a lack of understanding. It's that aging isn't one problem, it's 9 or more overlapping systems failing at once, each one propping up something else. Fix the cells, and you risk the healing process. Fix the healing process, and you risk cancer. Fix the DNA damage, and you're still stuck with a body that was never engineered to last this long to begin with. That doesn't mean it's hopeless. Every one of those mechanisms is now a real, active target for treatment, and human trials on several of them are either underway or about to begin. We are, genuinely, closer than we've ever been. But anyone promising you a single pill that stops aging is skipping over the hardest part of the problem, the part where fixing one piece of a 9-part system tends to break another. The real cure for aging, if it ever comes, probably won't be one breakthrough. It'll be a combination clearing out damaged cells here, protecting DNA there, restoring stem cells somewhere else, all balanced carefully enough not to trade one disease for another. That's a much harder story to sell than a miracle pill, but it's the one the science actually supports. If you want to go deeper into the research being done on this right now, there's a growing community of scientists and supporters working specifically on health span research, worth checking out if this is a topic you care about.